what is an estuary? So, I mean, the class is a bit smaller than I thought, so you might get more attention than you'd hoped. But I mean, can anyone tell me their understanding of an estuary or what they know in terms of an estuary?
An estuary is a spot where a river flows into an ocean where the fresh water and salt water is mixed and has a high productivity rate and high biodiversity rate.
On par, very much a very good description. So the lead up in the photographs, you've got all of the first three. So where the ocean and a river system or a freshwater source mix, where the river meets the ocean, and where there is salinity, so a mix between salt and freshwater, as well as where there's a tidal influence. So in terms of the formal definition that's given in our legislation, all of those are included. So an estuary is a body of water where it's predominantly or periodically open to the sea. It also has a rise and fall in water due to tides that is measurable at spring tide. So you can't always see this, and only when the mouth is open to the sea. But there is that change in tidal activity. And then an area where salinity is higher than freshwater as a result of the influence of the sea, and where you can see a measurable salinity gradient. So interestingly, we have a very wide variety of estuarine systems in South Africa, quite a unique range of systems that you don't always see. So while some countries have these enormous big estuaries of very different systems, South Africa has a range of unique estuaries. For example, just looking at a few of the basic differences, the Knysna estuary, located on the south coast, is a very big estuary. It's got a very big mouth, quite prominent in terms of what people know between the two heads, as they call the Knysna heads, but a system where a large ship or vessel and yachts and boats can all easily move in and out of. Then up on the East Coast, we get a number of different types of estuaries. So we get these systems that are a lot shallower, have a mouth that's a lot smaller, and these mouths aren't always permanently open. So you get situations where they close for a little while, the water is not as clear, not as much saltwater influence, and much smaller mouths. We also get systems like this that have no water. So they only flow on very rare occasions. So don't really connect with the ocean until there is quite a large flood or rainfall event, and then these small systems flow. So how do we actually classify these estuaries? How do we make management protocols or make plans based on the different estuaries when they vary so greatly throughout the country? So originally, Alan Whitfield produced a paper that had 5 different estuarine classifications back in 1992. These were the broad classifications being the estuarine bay, or a system that's permanently open, a river mouth, a system that's more strongly dominated by freshwater flow, estuarine lakes, where although it's open, the mouth can close, but also it's a much smaller mouth in relation to a large lake's body behind the estuary. And then temporary closed estuaries, or when you look in the literature, they call them TOCEs, temporary open closed estuaries. And this is a term that's quite commonly used in Australia as well, because we get a lot of estuaries there. But since then, research has shown that actually the diversity in this country of estuaries is much greater than that. So we actually need a better classification and more classification for the estuarine systems. So now they divide it into 2 types. So any sort of river outlet that meets the ocean, so where freshwater meets the sea, can be divided into estuaries as well as microsystems. So there are 9 different estuary types and 3 different microsystems. Again, some of them are the same and some of them are then additions. So we now have estuarine lakes and estuarine bays are still there. We're including a lagoon. Does anyone know what the difference is between a lagoon and an estuary? No takers? We've only got one in this country. Okay, so if you don't have a freshwater input, so it's a body of water that creates a backfill behind the ocean and moves into the land, but has very limited to no freshwater input. So that's kind of missing the requirement of where a river meets the sea. But it's still a system that we find in this country. So we have to have a classification for lagoons. Then we have predominantly open systems, estuaries that are open 95% of the time. And then temporary closed systems have now been divided into large and small systems. Similarly, the freshwater dominated systems are now small and large fluvially dominated systems. And then we've also included the category for arid, predominantly closed systems, which are like that last one that I showed you, where it's basically a riverbed full of sand until those rare occasions when the water flows. But then we also have some really unique systems where, because of high levels of rainfall in certain areas, you get these very short, very small systems known as the microsystems, where a freshwater body meets the ocean. And these are known as microestuaries, micro outlets, or coastal waterfalls. And they're a lot smaller. So basically, we've had this introduction to what the different things are that determine estuary type. And to make it a little easier, I put a whole lot of different icons or figures on the top of the screen. But again, I want to ask you, maybe I can see 4 people, maybe 5, maybe each one of you can try and identify what are one of the things that are involved in determining estuary types. So pick an icon and see if you can identify it.
One of the things would be salinity, as well as
Yes.
the water table level.
Yes, okay, so we've got these 2 here.
The one would be tides. The one with the
Yes.
2 years.
The tidal
yeah.
influence and the strength of the tidal influence.
Water. Yeah, she says the water level. Water flow. The river.
Water
yeah.
flow is down here at the end, is how much water and how much fresh water is coming into it.
Could the second one be the size of the river outlet?
Yes, so the shape of the mouth and how the mouth changes. And you kind of got the first one there too, because that's the one that relates to size of the system as well. So what are we missing? The third one?
I can see shapes, but
Well, that's exactly it, the shape of the system. So whether it's long, short, thin, fat, shallow, all of this changes how we identify the estuary. And I think the 2 we're missing are the 2 down here where the arrows show mixing or stratification. So how the salinity, the fresh and salt water mix is quite an important component of defining the different estuaries, as well as the sediment characteristics within that estuary. So we're not going to go into the table in depth. When we give you the slides, it's something interesting you can see. Something that I've done in all the slides is provided the reference from where I got the data. And also most of these, I've created a folder that will be shared with you that has very useful resources. Any reference that I've referenced on the slide is also in that folder, so you can go and have a look at it. But basically, this gives the different characteristics of those 9 estuary types. So it helps you when you're looking at a system to differentiate which ones. I mean, all of them have been named and there is a research out there, but this is just a nice way to understand why they called them that. So the next question is, now you've got this estuary, you come to visit an estuary, how do you delineate it? How do you decide what the boundaries of an estuary are?
could it be that it's a freshwater river that flows into salt water and not a saltwater river that goes back into salt water?
So
Or
to
am
an
I
extent,
misunderstanding? Am I not understanding the question correctly?
no, so I'm not looking for what would define it, but how, if you had to draw it on a map, how would you draw the extent of an estuary. So the most common one that people look at is where the water is. But what I've already shown you is that sometimes there is no water. So, I mean, on a map, the way you look at an estuary is the water body and where the water is. So just to give you an example, this is the Klein-Rivier estuary. That's also in the Western Cape. It's close to Hermanus. So if any of you know Hermanus, that's where this estuary is located. So to have a quick look, we're going to have a look just at mouth structure. And what I want you to focus on here when we have a look at whether the mouth is open or closed, what the water level looks like, what the water color looks like, and where the mouth of the estuary is. So we're going to have a look at a couple of satellite images that I took from Google just to show you how much this system changes over time. So if we look at those again, you can see that there's a huge amount of change in this estuary, and this was over a 10-year period. And that's only considering about 15 to 20 satellite images that were available. So this estuary goes through a lot of change in that time. We have situations like the first picture over here where the estuary is open and the mouth is sort of a quarter of the way across the system. The next image shows the mouth is closed but has some overtopping. So this is when high tide, you might have a little bit of connection between the water level at high tide or at spring tide. But also the water level is quite low, and you have a couple of these channels where the water was flowing, but there's now not enough water to maintain that flow. Then the third picture is the same thing where the estuary is closed, although there might be a slight bit of overtopping. If we look at the third image on the top corner over here, the sand is wet. So at the high tide, there might be a little bit of overtopping in that area. Can I just confirm, can you see my pointer?
Yes, we can.
Thanks. The fourth image on the top here is where the estuary mouth is closed and has been closed for quite a while. So the water level is quite low. You also can see quite a lot of green color. So you've got an algal growth that's occurred, likely also some vegetation in the area that's boosted because of this close and the more stability in the water system. Again, a case where the mouth is open, and in this case, the water is flowing quite strongly. So you can see that because of the color and the sediment transport that's happening in the estuary, quite a lot of flow picks up the sediment in the system and flushes that downstream. And that color can even be seen here out to sea for probably about 1.5 kilometers out to sea. The one in the middle here is again where the estuary mouth has been closed, has been for quite a while, and the water level is fairly low. Whereas this last one, which is a recent picture, is where the estuary, the amount of water in the system is high. Also, because this is in an area where we have a lot of fynbos, it looks like somebody's very strong coffee, because we have a lot of tannins in the water and the water's been sitting there for a while. And this very full estuary is ready to burst its banks. So this picture was taken in 2023. And this estuary actually flooded in September last year. So a lot of rainfall came down and this whole system flushed. Water levels raised exceptionally high, went up at least 4 meters from the regular water level. And that's not across, up 4 meters from the regular level. And it burst its mouth quite substantially. So this is another aspect of how we create the boundaries of an estuary, is we need to take into account not just what it looks like presently, but what it looked like over time, as well as to what extent it affects its local community. So a close-up of this picture where we can see that sediment transport that's moving out into the bay means that the estuarine habitat that is affected includes some of this marine area. So the step that's now been taken and what we use to delineate estuaries, or the estuary boundary, is something called the estuarine functional zone. So that is the exact definition of the estuarine functional zone. But basically, it means that we're not just focusing on the water body, but also looking at all of the specific processes involved in estuarine functioning. So what makes the estuary tick? What makes it work? This includes things like sediment transport, sediment erosion, floods and flood events, and how far the water level goes during a flood. Changes in the channel. So in that group of pictures, you saw that the areas of the channel are that dark. If we go back one, the areas of dark regions change from one to another. They don't always stay the same. And a big flood event also scours a system like that, changing those channels. So those are also important things we need to take into account, as well as coastal change that happen because of storms, as well as because of a flood or because of the extent of where the water moves or reaches, we get a change in the vegetation. And all of this means that we need to increase the size of the estuary boundary. So the estuarine functional zone was declared. And originally, or historically speaking, the way that they prepared these boundaries was looking at the 5-meter contour. So that's, as I said, it's not 5 meters from the estuary and on a flat scale. It's like topographical contour, so it's 5 meters above the water level, as well as looking at the floodplain and flood levels, and then vegetation types. More recently, in the NBA, the National Biodiversity Assessment, they've changed and improved this delineation by including a number of different factors. They now look at historical imagery. So we have satellite imagery, which is great. They look at aerial photographs. They take into account the combination of the 5-meter contour and the 10-meter contour. So many of you may not have traveled that far, but on the KwaZulu-Natal coast, for instance, there are a lot more mountains and lots more mountainous area. So all your estuaries are sort of what they call incised. So they cause little valleys, and they form at the bottom of a valley. So when you move up 5 meters, you're not going very far from your estuary. Whereas here on the west coast, we're a lot flatter. Going further north, it gets even flatter, and your 5-meter contour gets quite far away from your water body. And these are all things that they needed to take into account. So they included both the 5 and the 10-meter contour, depending on the region that they're working. They also included what they call contiguous habitat. So if, for instance, if you're driving in a car and you go around a very sharp bend, there's a small portion of that land, even if that land is an island, if that land is high up and above the 5-meter contour, now if it's surrounded by more than 75% of the estuary, it's included in the estuarine functional zone. So these bends and islands that are actually fairly important for the structuring and the functioning of the estuaries are now also included. So if we go back to our Google Maps image, then I went onto Google Earth and I found the one that best fit that, and also the one that had one image, whole image, instead of a patchwork of 3 different images. But if we only took the water body, it would be quite a lot smaller than the actual estuarine functional zone. So there you can see the light blue is the extent of the estuarine functional zone. And this is the habitat that is now considered necessary for the estuary to function properly. And as you can see, as I mentioned earlier, it includes an extent into the surf zone because of that interaction that happens when a mouth is open or when there's a connection to the sea. So the next question is, any of you want to take a guess, considering we've got 4 coastal provinces and a coastline that's nearly 3,000 k's long? How many estuaries do you think we have in this country? Somebody's sitting off screen. You're right.
Is it 300, more than 370?
More than 370. Okay, that's one guess. Anybody else want to warrant another one? Let's get 2.
50.
50. Okay, so our first one is much closer. So considering the new categorizations, we have 290 estuaries and 202 microsystems. So there's nearly 500 estuaries in this country. So mostly we focus on the 300, the larger of them, not the microsystems. That's quite a lot of estuaries. It's a lot of coastline. So how likely do you think that they're evenly distributed? Put your hand up if you think they're evenly distributed, leave it down if you think they're not. As in, how do they range across the coastline? I can only see 4 people, but everyone's hand is down. So take a look at the map. A little bit harder to see, but the light blue all around the coastline is our estuarine functional zones. So zoom in, and we can see that on the KwaZulu-Natal coastline and those areas where there's a lot more water, there are a lot more estuaries. Coming back this side, looking at closer in the Cape Town region, Longbourn area, far fewer estuaries. So if we divvy that up and look at that in terms of the different provinces, we'll see that the Northern Cape has only 5 estuaries and 4 microsystems. The Western Cape, 53 and 38. And the Eastern Cape is winning with 155 estuaries and 97 microsystems. And these two provinces share one here in the middle. The Blow-Krans estuary is perfectly on the boundary between the 2 provinces. So one in the middle. And then looking at the KwaZulu-Natal coast, we've got 76 estuaries and 63 microsystems. So a lot of estuaries in the country and a lot of research that needs to be done. Thankfully, quite a lot has been done in this country. So I mean, again, hands up if you think that South Africa is advanced on estuarine research or behind on estuarine research. Up is advanced, down is behind. The cynics in us, and most of the class, there we go, okay, they're coming around, think that South Africa is behind on estuarine research. Actually, we're doing phenomenally well. This country has a great base of estuarine researchers at the moment, a lot of which are doing a lot to advance our research and our knowledge on these estuaries. So that despite the fact that, remember, those 290 estuaries, 202 microsystems, we actually have a really advanced knowledge on these systems. And this includes a method to assess estuary health, something that New Zealand doesn't have. So they get so much rain that they have huge numbers of estuaries as well, a lot of water running into the coast along a big coastline, and they don't have a standardized method for assessing estuary health. South Africa does. So once every 5 years, we get this really nice research project that comes out, the National Biodiversity Assessment. It's for biodiversity across the country. It includes terrestrial, coastline. But the one that I like looking at, and the one that's most valid to me, is this, the estuarine realm chapter. And in this, they provide detailed information, not just on specific estuaries, but they also provide a lot of the literature and the reasoning and the importance of estuaries. So a lot of understanding about estuary goes into this report. And included in that is an assessment of the estuary health of these estuaries. So that which you can see on the right-hand side of your screen, all that color is an assessment of estuary health and different factors of estuary health for a number of different estuaries in the country. So we're going to take a look at how you would assess estuary health, or how this system works. So obviously the first thing you do is you're comparing now, or the health of the system now, to what it should be or what it was. So we compare the state of the estuary today compared to what it looked like historically or in a pristine situation. And you give a percentage account of what that is. There's quite a lot of maths, tables, and data involved. I will show you some of those, and you're going to try and do some of those. But what we do is we get a percentage value, and those are then categorized into one of 7 categories. from an A to an F. So we also now recently, the NBA introduced in 2018 these straddling categories where it becomes quite difficult. What if I have, for instance, a 75 when the category B is 90 to 75% and category C is 75 to 61? So now you're sitting on the fence. And what they've done is they've introduced these straddling categories. So it's then a BC, which is 3% above and below the boundary. So for example, if we look at an estuary that is 91% or above compared to pristine, it's nearly pristine, is considered a natural system. A B is a largely natural system. And these two together are called natural and near natural systems, which are considered to have most of their processes and environmental functioning still intact. Something that's a D, so between 60 and 40%, is something that's called heavily modified. And this has undergone a lot of heavy change, a lot of modification due to human activity, and is considered to have lost a significant part of those processes and patterns that are important for the functioning of the estuary. And then here on the end, which when I show you the table later and you look at the colors, so remember the colors mostly, on the bluer side is healthy and on the browns is unhealthy. And the darker end here, we've got extremely degraded systems or systems that are severely or critically modified. And those are systems where most of the processes are completely lost, where they've undergone so much change that the natural processes that used to be involved in managing these systems are no longer available. I won't go through them all, but also at the bottom here is a bit more detailed description of what each of those entail. So again, we're going to go back to our icons. We're looking at estuary health, and it's divided into these two factors. We've got abiotic or physical and non-living factors, and then we've got the living factors. So you're up again. Pick a picture and tell me, and let's avoid the salinity, we know that one, or flow. Try one you haven't seen before and take a guess at what you think the abiotic factors are that we try and look at, and what are the biotic factors when we assess estuary health.
From the new abiotic factors, I can see flooding and temperature differences.
Yes. Someone want to have a go at biotic factors?
Is that the biotic factors now? So
Yeah.
that would be predators and like the production by phytoplankton. Maybe competition.
Yeah. So those, I mean, competition is an important one. Thankfully, we don't have to look at competition when we're assessing estuary health, because that's going into a lot more detail than we'd like to. But yeah, if I take from the top, flow, we've looked at. Your colleague in front there mentioned the flooding, the state of the mouth, the mixing and the stratification in the system, how that water changes based on the incoming tides. Residence time. So this one over here is residence time, which represents how long the water stays in the estuary before it moves out of the estuary mouth. Water level, physical habitat. So looking at bathymetry, sorry. So that's actually like the depth of the estuary, how it changes. Looking at the different zones and how the physical habitat changes. So we've got intertidal zones. So if a lot less water flows into an estuary, we're going to get a lot more intertidal zone. But if the estuary mouth closes all the time, then you won't have that fluctuating water level and you'll lose that intertidal zone. And that's the zone between the shift in water level where a lot of the organisms occur. You're also going to get changes in your subtidal zone, your salinity, your water quality. And those are the physical aspects we look at. And the biotic ones are the key features. We don't go into too much detail, thankfully, but your microalgae, your macrophytes or large plants, your invertebrate species, so the little critters in the sediment and on the sediment, fish and birds. And all of these together are then used and weighted in assessing the health of the estuary. So again, in this, you can just see it's divided into the 2 factors, and the number on the top represents what weight each factor contributes to the overall estuarine health. So it's a 50-50 split between the abiotic factors and the biotic factors. And then each of those are subdivided. You have hydrology, which is your water flow and the way the water moves in the system. Hydrodynamics, similarly looking at mouth state, stratification, retention, water level. The physical habitat, or those zones I talked about, as well as your bathymetry and the volume of water that's in an estuary at any given time. And then the water quality, it says salinity and general, but the general is then subdivided into at least 4 categories, where we look at the clarity, the dissolved oxygen, the nutrient contents, and toxic substances. And then the biotic factors are all looking at the richness, abundance, and the community structure. Because in some cases, you can have a complete change in the community structure, but still have the same number of species. And so we have to consider all of these aspects to be able to determine the estuary health. So there is a variation in how well we can do this. So there are different categories of assessment or different levels of assessment, all of which are dependent on the information and the data we have available, which is always the biggest issue, is give me more data. I always want more data. So if, for instance, we're doing a desktop assessment, that's me sitting on my computer, doing a literature review, looking for the available information and looking at satellite imagery, which means that my confidence in the assessment of the health of the estuary is fairly low. If I do a rapid assessment, my confidence comes up a bit. I'm a bit more medium confidence level. This is because I have a little more data, and I usually include a site visit. But this is maybe a one-day site visit. So I go into the field, I can maybe do a bird survey, I can look at the mouth, I can look at the vegetation in the area, but I can't tell you much more about what's happening in the water. So an intermediate level, we're increasing our confidence, moving up to medium high. This is because we have more data. We go into the field, usually spend 4 to 5 days in the field, collect a lot more data, a lot more samples. We actually conduct a survey where we collect water quality, we collect fish data, we do the full table. And then a comprehensive determination is high level of confidence, and this is because we have more data, but we also do a far more in-depth survey. Usually this means 2 surveys, so you go back seasonally, because things can change from one season, the high season, to the low flow season, whether the mouth is open or closed. So it's all about the level of data, the time available, and your funding, unfortunately. But how much information you get determines the level of the estuary health assessment that you can do. So again, makes for a great field trip, going to the field, and you've got to collect all of these different things, put instruments in the water, collect your invertebrates, do fish trawls, do bird counts, get your binoculars out, learn a couple new species, collect water samples and analyze water samples, go bundabashing in the vegetation, which happens a lot in KwaZulu-Natal. In my full waders, should have put a picture of that in. It's like gumboots that are connected to like perfectly watertight dungarees, which is not the most exciting thing to be doing in the humidity in the Durban area. But I do not have an affinity for snakes. So when I'm bundabashing in vegetation that comes up to my thighs, I'd really rather not be too bare-legged. But all of this includes out in the field collecting this data so we have information to do our estuary assessment. If we're lucky, there are existing meters in the estuarine system. It's the one place where we are unfortunately strongly lacking information is the flow of water. So sometimes we're lucky and we can get data. Sometimes there are existing flow meters. Sometimes we model the data based on historical or limited flow data from different points in the system. And we use that and other samples to create these great sort of indication of data and what's available, and we look at how it changes. So for instance, here we're just looking at salinity in a large, predominantly open estuary. and how it changes in a summer and winter rainfall period. So on the KwaZulu-Natal coast again. So here our summer rainfall means high rainfall, and our winter means low rainfall. And then we've got the two different tides. So at the top, you can see here, we've got high tide. And because there's high rainfall and so much freshwater flow, the seawater has a very small influence. It only penetrates, what's this, in less than 2 kilometers upstream. And during the low tide, when the water is all flushing out of the system, it's completely fresh. Whereas if we look at the high tide in winter, and of course our winter sampling period was shortly after quite a strong rainfall event, which, you know, you can't control nature, means that this is still quite a fairly high river flow. But during the high tide, you see a much stronger influence by the seawater. So there's blue coloration, and that indicates greater extent of seawater moving into the estuary. And then the low periods, you're still getting some seawater dominance at the mouth of the estuary. All of this information is stuff that we collect, that we have to graph and map in order to do an assessment of the estuary health. So now I'm going to open up a whole lot of things, show you some data, and we're going to give it a try. So the first thing that we'd probably look at is Google Earth. Okay, hands up if you want to go East Coast, and hands down if you want to go West Coast. Okay, I can only see 4 people, I'm afraid. Oh, wait, we got, okay, so I can see 3 hands for the East Coast. So we're going East Coast. So if I zoom in like that, okay, hands up again if you want to go to the northern end or the southern end. Hands up for north, down for south. Ah, everyone wants to go north. Okay, so we're going into KwaZulu-Natal. Do any of you have a particular estuary you want to try and assess in KwaZulu-Natal? Or should we just sort of like run my mouse slowly along and you say stop? No particular estuaries? No. Okay, so someone in the front there, you two in the front, someone grab the microphone, and I'm going to slowly work my way from top to bottom. And when you say stop, we're going to go to the closest estuary.
Okay. And stop.
Stop. Oh, I've just done a survey at this point. Okay. And it's one I can't pronounce, which happens more often than I'd like to admit. It's not the estuary I thought. But okay, so we got to the Matigulu estuary. Sorry if I pronounced that wrong. I have no ability to manage these. So earlier I mentioned that we have this national biodiversity assessment. And along with that, we have this amazing amount of data for all of these different estuaries. And what I've done, I mean, most of them came in, there was a number of different Excel spreadsheets. What I've done is I've collated them into a single Excel spreadsheet with multiple tabs along the bottom here. This is something that's included in your resource pack. It's great fun to go and have a look at the random estuaries like we've done now. Choose an estuary and go and have a look at it. The way that this works is that the first tab, or the numbered tab, is the sort of README tab. These are the instructions for the next set of data. They also give you the reference. So if you use this data, this here is the reference for who you reference, because a lot of work goes into collecting this data. And it gives you the information. So the first tab is, this is all of our estuaries. This is the estuaries as well as the estuarine outlets, the small microsystems, all along the coastline. So in the end here, we get to 492. And they're all divided into the name of the estuary, the class, the region in which it falls. We get its old classification, its new classification, names. So many of the estuaries, especially along the KwaZulu-Natal coast, have multiple names. So different variations, like let's find one. So that might just be spelling, but this estuary has I really shouldn't choose one that I can't pronounce, should I? One name and 4 different aliases. So it's the same as like the Tugela estuary. That's like, I know the Tugela from like, if you've gone to the Drakensberg, or you know the Tugela waterfall. Tugela estuary, which is down south, is on the far east coast, has 4 different ways to spell. Sorry, I just deleted that. Has 4 different ways of spelling for that estuary. So this is a very useful thing, because if you go and someone tells you you need to do an assessment for one estuary, and that's someone who's local in the community and they're calling it by the local name, and then you want to come and assess it and you go and look at the NBA name and you can't find it, this is where you go. You come and have a look at this. It also here, which we're only going to look at quickly, has all of the main estuaries. So there's 9 estuary types, the 290 estuaries, their location, as well as a classification of their health. So remember I said that blue is healthy and the browns and the dark browns are unhealthy estuaries. So we start here at the Orange River on the west coast, and as I scroll down, we go around the coast and finish on the very eastern, the northeastern border of the country. And you'll see that the estuary health changes. And we have areas where over here, we've got some great looking estuaries, some fair estuary health, and then an area of the wild coast, which obviously is not very accessible and doesn't have as much urban area. We've got quite a lot of healthy estuaries. And then moving down again, moving up into KwaZulu-Natal, and you're starting to see estuary health decline again. So that's giving you a little bit of an idea of where we're going. It then has a section on how you look at the importance of the estuary, classification of the estuary in terms of its importance in as a fishing nursery area, its importance for biodiversity for the country or for a region, as well as how close it is to any protected areas and things like that. It gives you an assessment of the pressures in the estuary. It gives you an assessment of, like you have the IUCN. So I don't know if you've heard of the IUCN and how they rate different species as being vulnerable or at risk or endangered. We're doing the same for different categories of estuaries. And all of that is provided here in this data that we have for the South African estuarine systems. And they've all been classed into a specific category. They've also gone as far as saying, what are the restoration methods required? What are the things that this group of scientists believed were necessary in order to help improve estuary health? And then there's some great stuff on the vegetation. So a lot of work done by a group that's now the research chair for estuaries, Janine Adams at Mandela University. Her group and a team of her put together all the different species of vegetation you might be able to find in an estuary, the different aliens that you'd find, the different species in each system. And all of this is available in this one Excel spreadsheet. So we're going to go back and I'm going to find the name of the estuary you chose. I'm going to copy that so that I don't misspell it. And we're going to go find it in the Excel. And this is what I've created. So this is how we normally do it. We look at those different components. So what we had, like I had earlier, is that divvied up of the different things, the hydrology, the hydrodynamics, the water quality, the physical habitat. You are going to give me a score that you think the estuary is at. First, we're going to go and look at the different pressures that this system is under. We're going to have a look at it with the satellite imagery. And then you guys are going to give me an estimation of how well you think it compares to the pristine. We're going to fill it in. So let's put it 80, for instance. I'm going to then say, okay, that comes 80 falls here. That's a B. And this thing's very nicely going to fill in for me my color and my category. And all of that in the end will calculate to a value that will then give us what the estuary health as your assessment is. And then we're going to go and get what it is on the NBA and see how well you did in our rapid desktop assessment. So using the available information that we have, we're going to go back here. Oh, wow. The estuary you chose has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different synonyms. So I don't feel so bad for not being able to pronounce it. And so going forward, it helps when you know the estuary number. So in terms of the health assessment, we use the second estuary ID, which is the estuary types, those 9 categories. It's not all of the estuarine systems in the country. So our number that we're looking for going forward is 281. So it means I don't have to spell it every time I look for it. Obviously, you're in the KwaZulu-Natal. It says this is a predominantly open estuary. So we go and look at it on the map again. And it does. It has quite a large estuary mouth. So if I turn off here, you can see it's got quite a big estuary mouth. What's interesting is you can see that it spreads all the way along. So your estuarine functional zone, oh, and looking at it there, we put that back on. That looks like the mouth. There's where the water is actually running out. So even this assessment from the 2018 NBA is not enough. So the extent of this estuarine functional zone is actually shorter than the true estuarine functional zone, because in this image you can see there's where it exits to the sea. So always an interesting thing, and how the research and everything changes constantly. So predominantly open system. In the KwaZulu-Natal coastline, doesn't look like a very fast flowing river. Mostly around it, as you can see, there's not a lot of urban area. So a lot of this will be classified as in traditional land. So you've got some, if you zoom in closer, some farmlands and some housing, but not that much in the way, I mean, just if you want to compare for a second, let's go and have a look at Durban. This is Durban's estuary, and that's the amount of urban area that is occurring in the Durban estuary. So you've chosen an estuary that presumably has far less human impact than, for instance, the Durban estuary. So let's go back and find our system. Okay, so what do you think the pressures, like, I don't know, give me 2 or 3 before we go and look at our nice estuary information that'll tell us what the pressures are for this system. Can anyone tell me something that they might think affects this system?
Seeing as it is very rural, could it be that people could go to the river to do their washing, or that their waste could be flowing down the river through the estuary?
Okay, so water quality impacts could be one of the things. Yeah, definitely. Some of the other things that may affect it is, one of the biggest things that always affects our South African rivers is the use of the water. So how much water is reaching the system. So the flow and the incoming flow. So we're going to go back and have a look at what pressures are acting on our system, which I said was 291?
81.
81. Thank you. There we go. Okay. So I don't know if we... So I'm going to put our estuary on the very top line. And this is the different things that act on the key things, the most common things that act on estuaries. And they give the rating of those pressures. So the first is obviously the cumulative pressure. The overall pressure for this estuary is considered low. The pressure in terms of flow modification is also considered low. So not too many people using that water. Pollution pressure low. Habitat loss. So this is one that's often very high when you have a lot of urban area, because you have a lot of development in these areas. Low. Fishing pressure. So there's one that's very high. So perhaps a local community is not using the water so much or polluting the water so much, but they are fishing and so exerting a high fishing pressure. It says there are no alien species of fish reported in the estuary. There's sort of unauthorized breaching. So one of the things, as we've mentioned, is we have these open closed systems. So estuaries that naturally close during certain times of year. And one of the biggest problems with this is if you wanted to build a house by an estuary, where would you put your house? You know, as close to the front of the estuary so that no one else can hide your view, no one else can take your space, and you get the nice natural environment. The only problem with that is that at the time, the estuary might be 50 meters away. But we've seen that the way they change here in South Africa is quite phenomenal. If the estuary mouth was open when you built your house, there would be low levels of water in the estuary. If the estuary mouth then closes and the water starts to back up, the first thing that happens is somebody's septic tank lands up being flooded, and then their house, etc. So this is why artificial breaching is quite a common and significant problem for the South African estuaries, is that people go and manually open an estuary mouth. Now, I meant to download the video, I didn't. You guys can go and Google it, but look for people opening a river system, opening an estuary mouth. Like they dig a little channel like you used to build a moat around your castle on the beach. They do that, and when an estuary is close enough to breaching, it can open. But that's not a system that was going to breach. It might have taken another 2 or 3 rainfall events for it to have done that naturally. And now you've forced it to open early, so there's not as much water that there would have been, and you're changing the dynamics of the system. So opening an estuary mouth too soon can be as problematic as not opening an estuary mouth, because of the human influence that it could have. So that's what this artificial breaching signifies. Then we've got pollution from wastewater treatment works. So there's no wastewater treatment works, because in the old days, it was completely normal and natural to discharge your effluent from a wastewater treatment works into an estuary. They still do it today, but no new wastewater treatment works are allowed to discharge into an estuary. Pollution sources, they haven't got any. So usually these are urban or agricultural sources. Similarly, the only thing here says it's got marine plastic pollution as one of the things that's affecting this. And then it also says sand mining is one of the issues. So a lot of these KwaZulu-Natal coasts, because they need sand for developing and for building, estuaries are a very easy place to get sand. And so that's one of the big impacts on a lot of the KwaZulu-Natal coastlines, is the sand mining. So those are the pressures that this estuary is currently looking at. So if we go and have a look, for instance, at its threat status. It says it's an endangered estuary type that has a moderate level of protection. So if I turn on the map, we can see maybe if we turn on our protected areas, there's a marine protected area just offshore, the Tugela Marine Protected Area. There's also something small here. Also the Tugela, oh, that's the shoreline version of the Tugela Marine Protected Area. If we turn on our land-based protected areas, oh, it's got a lovely protected area here, a nature reserve across much of the estuarine functional zone. So this purple and the pink there is so that's more than most estuaries. So it's got quite a high level of protection, and it's an endangered system. So let's go back here. and see amongst you. If we want, what I can do is do this as I often, so let's go back to our pressure assessment, look at our main pressures. Oh, sorry. Let's just change this. So I'm just going to copy the pressures just so that you have those and you can have a look at those as you try and okay. So anyone want to take a guess, or between you, if you want to talk and think hydrology. So this is the amount of flow and fresh water coming into the system. It says that the cumulative pressure is low. So what percentage would you like to put there?
Seeing it as it is open, I was thinking close to at least 85%.
85%. Okay, which is a B. So we put this as a B. Okay, hydrodynamics. So if you remember back to that, that's talking about the bathymetry, I can open that again if that makes it easier. The change in the subtitle, the salinity, and all of those impacts. So how the hydrodynamics, the state of the mouth, how that varies. How much do you think that has changed compared to a pristine state? It's also how often you think the mouth opens and
I feel like it changes rather often since the mouth has moved outside of the protective area. So is it a lower percentage if it changes often?
so it's how much it changes from pristine. So yes, if you think it changes more regularly as opposed to where its extent. So it's not so much of the, yes, it's not within where they expected. It's more about how often you think the mouth is open or not.
Probably open often, so I'll probably give it also a 85 around there.
Okay, so similar to what it used to look like. Water quality. So again, it says the pressure level is fairly low.
Oh, because there's low pollution. The water quality, I'd also give it an 80.
80.
Yes.
And 80 is still in a B. So here is the weight of each category is 25%. So these are all evenly weighted. So it makes for quite an easy equation. I've just got an average in this equation, but it's just calculating it as we go. So the final one we want to add is the physical habitat alteration. So how much do you think the habitat has changed? The sediment, the amount of intertidal or subtidal, the depth of the estuary, how much that has changed compared to its natural state.
And that was being removed, I would guess it could be closer to 70, but other than that, there hasn't seemed to be much change.
Okay, so 70 still falls within our B.
Is it not in C?
Oh, sorry, you're right. I'm in the wrong category. Thank you. So yeah, 70 is within our C category. So there's our first C. Now we're going to move on to looking at the abiotic factors. The biotic factors with our health score for the abiotic at an 80. So the first thing we're going to look at is microalgae. So I think what you said in the beginning, really early on when you gave me a definition for estuaries, we said it was a highly productive area. So an area where we get a lot of algal growth because we have this dynamic system with the changes in salinity and the changes in community. So things that would affect water quality are the introduction of nutrients. So if we have a lot of nutrients, your microalgae spikes and you get blooms of microalgae. Or if you get a period where it's closed for a very long time, your community shifts compared to when it's open and you get an influence of species from the sea. So given the pressures and the states that we've seen in the estuary, what do you think in terms of how microalgae have changed compared to their natural state?
Due to the estuary being predominantly open, and even though the river is quite slow moving, I would still assume that there aren't that many of microalgae that grow there, or at least not, it wouldn't change from what it usually is. So I would probably give that a 90%.
90%. So we're going high, close to an A, but not quite. Macrophytes. So these are both the vegetation on the edge of the estuarine system and within the estuarine functional zone, as well as anything within the estuary. So one of the things that I didn't transfer across from your pressure statement is alien species. So if we go and look here at alien vegetation and find our estuary, this one. I see one. So here we've got a single alien species, which is found in the system. I think that's the sea lettuce.
Jess?
Yeah.
I'm just checking, did you check the right one now? I think you went to 291.
Yeah, sorry, it's number 291. That one isn't cell number 291. That's not, so there's our estuarine system.
Okay.
This is not the actual estuary numbers, that's just cell number. So I was looking for the estuary name. It's something we could edit in it. But yeah, so there's only one species of alien found in this estuary. So that's also always something we need to consider when we look at the macrophyte health. So then what's your estimation for that?
I believe it's very high, so probably say 88.
88. Okay. Invertebrates. So these are the critters or the chochos that live in the sediment.
It should also be quite high, so I guess we can just go for 90 again.
Okay, 90. We're sticking with the bees. Fish. So remember, if you look at your fishing pressure, it says it's got a high fishing pressure. It's not very high, which is also one of the categories, but it is high.
So this one will probably be closer to like 65 then.
65. Okay, so one of the things, if you look at also is for the different factors we're looking at how the species richness changes, the abundance and the community structure. So those are all things that you take into account. Because for instance, sometimes if you get the introduction of aliens or the removal of one species and the introduction of another, your species richness will look healthy because the number hasn't changed, but your community structure has changed. So here you gave it a 65, which puts us in C. And the last one we're looking at is birds. So they're in this order also because often in an estuarine system, you have what we call cascading effects. So the birds eat fish and invertebrates. The fish eat the invertebrates and the plants, and the macrophytes are dependent on the microalgae and such like. So it's a cascading effect. So usually if you start to see negative effects occurring in your lower order biotic factors, they do travel up into the higher order biotic factors. So what do you think the birds within the system look like?
It would probably still be quite high because there are quite a few invertebrates for it to feed on, and the human activities aren't that high. So it'd probably be close to 85% still.
85. Okay. So B. So here we have our score for the biotic factors is 83. Score for the abiotic is 80. Because they're evenly weighted at a 50-50 ratio, your health score that you've given this estuary is an 81, which puts it solidly in a B health score. Oh, that one doesn't. Okay, so let's go and have a look. If we go to our estuary health, we find our estuary B, a near natural. Let's copy. Let's just see. I just want to check. I think it has an extra category that I might not have counted for. So hydrology, hydrodynamics, water quality. So I reckon for a first attempt, that's a pretty good one. So mostly your assessment of hydrology, hydrodynamics, water quality, and physical habitat are close. B's for the first three. We assessed physical habitat as A, and the reason you gave was likely because of the sand mining pressure. Evidently, it's not as high, and there hasn't been much change to the system. And so in the 2018 assessment, they rated that as an A, which is a natural. Microalgae, they've given it as an A, so very little change in the community structure, composition, and species habitat in the microalgae. You've got the right assessment for macrophytes and invertebrates, even for fish. That's a great one. And so because of just one or two changes, this estuary health comes down to a C. It's a little difficult to compare because you don't know what their actual percentage is. And that we have very similar assessments elsewhere. So it's very interesting. It might just be that their categories in terms of these were not as high. So for instance, you said an 85 is a B, whereas the lowest of a B could be a 75. So that's a possible reason, but this estuary is actually classified as a C. So a very good first assessment. I don't know if you guys want to try and do one in an urban area. Do you think that'd be easier or harder? Or maybe let's just look at a big estuary. Do you know any ones you know and want to guess at what you think its health is?
We can try the St. Lucia estuary.
St. Lucia, okay. So let's turn off. So here's our biggest estuary in the country. And we're going to go and delete these and go back again. So let's look at pressure assessment for the St. Lucia estuary. I'm going to copy, this one's going to have a couple more. So I'll copy all of these. Okay, so the cumulative pressure, maybe let's have a look first at the actual system. Let's switch off here. So don't forget that you've actually got this one here is the Umfolozi. So we're not looking as far as this one. We only want to look at the St. Lucia estuary. I might turn on. So this is in Google Earth. You can change the time that you're looking at the system just to make it one where we can see a bit better the actual water body. But there you can see this is a very big system. It's a complete 360 square kilometers, I think, of water body, 3 lakes. So this is considered one lake, and the North Lake, South Lake, and then the South Lake, sorry. And then the Narrows is this sort of narrow bit through here to the actual mouth of the system. So here at the mouth of the estuary, you've got the small town of St. Lucia, but you've also got a lot of sort of urban, semi-urban area here in the adjacent catchments. So some, if we turn on the estuarine functional zone again, some of the catchment on either side of these 2 estuaries will have this urban area. What you can see here is a lot of agricultural stuff, a lot of forestry, some more agriculture and forestry on the side here of the lakes. Not much in the way of dense urban development, but coming in here, we've got quite a lot of community. I know there's a significant traditional land area along the northern reaches of the system. So let's have a look at some of our protection status, turn on marine protected areas. And here you've got the Isimangalisu marine protected area, which is quite a big system all the way along. It goes right the way up to the northern border of the country and includes the Cozy Bay Lakes. And I think all of these are just different colors of the same, the Isimangalisu protected area. If we look at the land-based protected areas, it also has a significant, much of the estuary is within a protected area. So this is Isimangalisu Wetland Park, which just about includes, if we turn our functional zone back on, just about includes most of the functional zone. So quite a nice area there that's protected. Okay, so now that we had a look sort of at the satellite imagery and what's happening, I haven't turned the rivers on. I could turn the rivers on for you. And you can see the different rivers. It's 5 or 6 rivers that flow into the system. So quite a lot of influence if you look at the broader reach of where all of these catchments would be going. All of these river systems also influence the system. So cumulative pressure level is considered high. Pressure in terms of flow modification is low, so not a lot in terms of those 5 rivers coming in. Pollution pressure, medium. Habitat loss, medium. This habitat loss probably relates to both some of the urban development close to the mouth, but also a lot of that forestry habitat. Fishing pressure, very high. Invasive plant species and medium. Alien fish, it says no alien fish in this system at the moment. Artificial breaching is considered low. So because it's such a big system, there's a lot of sediment to move. I have seen them breach the mouth artificially once, but it's not got a lot of sort of unofficial breaching. No wastewater treatment works, limited catchment pollution, noise pollution, it says medium noise pollution. Sand mining has some sand mining pressure, but it also has a level of protection. Fishing pressure, so changed between 2011, where fishing pressure was considered high, to very high. So interestingly though, take a look at that. In 2011, the assessment of the number of tons of fish caught is 10 tons. In 2018, it's 296 tons of fish. So a lot more fish that people are catching in the system at the moment. So there's why our fishing pressure has gone up so much. And then bait collection. So people are collecting both sort of critters in the sediment as well as some of the fish species for bait collection. So these are the pressures acting on the system. The one other thing we can have a look at was go and have a look at the vegetation. So alien vegetation. Let's go find the St. Lucia estuary, and there we've got, oh geez, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 alien species of vegetation present in the St. Lucia estuary. So let's give it a go. Hydrology, river flow.
This one will probably be lower than our previous assessment, so it's most likely closer to like 65%.
Okay, 65 is our C category. Hydrodynamics, so mouth state, salinity changes within the system.
This one will probably be, I don't know if it would be higher, because we don't necessarily know if the mouth is open consistently. But you did also mention that it is artificially broken sometimes, even if it's incredibly difficult. So it's probably close to 75% then.
Okay, well, let's add that and then I'll come back here. I forgot 75%. So then let's go back. I forgot to come and let's do our original assessment. The St. Lucia system is an estuarine lake. Has a couple of variations to the name in terms of some extensive ones there. Rio de Mendes de Oro. And if we want to take a look quickly at what the mouth looks like. So one of the things that they did historically in order to try and improve water quality in the system, because the mouth was closed for so long, was they joined these two estuaries. Originally, the two used to merge quite frequently, but because of a lot of sugarcane farming, so you can see here, the catchment of this estuary has a lot of sugarcane farming. And in order to prevent the flooding of their fields, they canalized this river system. So the water flow changed and moved more out to sea than into the St. Lucia estuary where they were originally merged. So this river system became separated and you've got the two estuarine systems. But they have since, in some cases, merged the two systems, and you have these back channels that they opened up in order to create this connectivity between these two estuaries. So if we take a look back in time for a bit here and see, I know they also just had a project that was millions of rands, if not billions of rands, in order to shift some of the sediment and improve the mouth state. But here you can see, for example, here a couple of years back, it was completely closed. There's open again. Let's go back 2018. It's not wanting to find a picture, but it's only in more recent years that the mouth has opened, some of which was, as we said, due to artificial bleaching. So our 75 is a BC.
Yeah, that's a bit high then, I guess. So I would rather put that firmly in C with a 70% then.
Okay, I'm going to drop that to 70. Water quality. So factors that relate here are salinity, but also your turbidity or the clarity of your water, the amount of pollution, so nutrients within the water, toxic substances, dissolved oxygen rates.
This would probably be closer to 60%.
Closer to 60.
Yeah.
So now we've got a CD. I wonder if it colors. So that's a nice straddling category there. As you said, 60 was sort of on the boundary between these two. And the straddling categories are plus or minus 3 from that boundary. The boundary then being 60. So up to 63 and 57 would fall in this boundary category. Physical habitat. So how much has there been physical change to the estuarine functional zone? Change to the amount of subtidal and intertidal habitat, changes to the bathymetry or the depth of the estuary.
I'd say that it's very low, so maybe, let's say 55.
55, a lot of change to the physical habitat. D. Okay, now we're going to have a look at microalgae and all the biotic factors. So remember, we said changes to microalgae come from changes in the community structure based on what your salinity is doing, your connectivity, and high amounts of pollution would input changes to the abundance.
It would probably be around 80%, still very high.
80%, looking fairly healthy in this area. How about the macrophytes? So these are the plant species. Interestingly, the St. Lucia estuary is one of those who have mangrove habitats. Mangroves are species that like to have their feet in salt water. So variations that would happen to mangrove species are dependent on changes to the state of the mouth, where you'd have more mangroves with the mouth open and less mangroves when the mouth is closed. So yeah, how do you think the macrophytes have changed in this community?
This would be slightly lower due to all of the alien vegetation species that were introduced. So it could be probably closer to 70%, 70, 75-ish.
Okay, so sitting in the sea. Invertebrate species? These are your crabs, your worms, your critters in the sediment. One of the things that might translate here is that I think we said they've got bait collection does happen within the system. Although you have given your primary producers a fairly high score. So how do you think the invertebrates would look?
I would say they're also around 70.
Also fairly healthy, and you're heading into moderate change. Fish. So this is the one where we've gone from, what, we've gone from 10 tons of fish collected annually to 296 tons of fish collected annually. Very high fishing pressure.
We're gonna give that on a 45.
45. And then the last one we're looking for is the birds. So St. Lucia is what's called a Ramsar site, which is an important wetland site. I think it was one of the first declared Ramsar sites in the country. I could be wrong, but I'm pretty sure it was one of the first declared Ramsar sites. And because the lakes are so shallow, it's a really cool birding area because a lot of birds come to feed in and around the estuary.
Okay, because we have high invertebrates, we'll give it a 80. 75, 75.
Okay, because also many of these bird species that we look at are what we call the water bird species. Many also are piscivorous or fish-eating species. So you've also given your fish quite a low, so it might translate. So we'll have a look at what it compares BC to what the NBA assessment did. So here we've got a 62 for abiotic and a 68, which brings our average to 65, which gives us a C category for this estuary. So let's go and have a look at what the NBA says. Do you think it's easier to do an estuary that has a lot of human activity or easier to do an estuary that doesn't have a lot of human activity?
Easier for the one that doesn't have human activity because everything would be high.
Yeah, it's also a lot harder to interpret. So while we have a certain ability to interpret how we think things would change, it's always quite difficult because nothing in the natural environment is easy. And sometimes we think that something may react a certain way, and actually it reacts in a completely different way. So here we can already see some changes. The overall estuary health is considered heavily moderated and a B, and we had it as a C. B. Okay, so let's have a look at some of the changes. Hydrology, they said, is a B, so they did indicate a low amount of flow change. This is quite interesting. It's the amount of pressure that comes from the freshwater flow coming into the system. Interestingly, I would have thought that that was lower myself. B is pretty near natural and is very good for an estuarine system. Hydrodynamics is an F. So a big change in how the system operates. So what the bathymetry of the system looks like, how changes in intertidal and subtidal salinity. So let me just show you something here that might help. So because we've had such significant sort of change in the climatic conditions within the system. So the St. Lucia estuary is not really dominated by summer and winter. The St. Lucia estuary has what they call a cyclical change of somewhere between 5 to 10 years of wet and dry periods. And I mean, here you can see we've had quite a lot of rainfall and evaporation. What's this, 2016? A lot of open area there, a lot of sand exposed that used to be subtidal. In 2013, when I was doing my thesis, my one site totally disappeared. So there used to be water, and I was collecting samples, but unfortunately it completely vanished, and they don't seem to have a satellite image better than this one. But this whole estuarine area that has water reduced to 10% of that amount of water. And a lot of this related to the changes that occurred here between the connectivity of the two systems. So there is an explanation as to why your hydrodynamics is so low, because this is the functioning of the system in terms of salinity and that sort of thing. And because at the time, the mouth of the estuary was closed, you weren't getting a constant flush of water from the estuary mouth, but you had a system that was also getting very limited amounts of fresh water. So salinity, can you tell me what normal sea salinity is? What's the value for the sea? Do you guys know?
$35 ppt.
35 parts per thousand, that's it. So salinity within the St. Lucia estuary got as high as 200 parts per thousand. It became incredibly hypersaline. And that's because it's such a shallow and such a big area. You had water come into the system that was salty, that was 35 parts per thousand. Because there was a low level of freshwater contribution, it extended into the lakes and into this upper reaches of the estuarine system. And then you had little to no fresh water. So you went through one of these cyclical periods of a low water contribution. But you're in KwaZulu-Natal, where the summer temperatures reach up to 40 degrees. I did some of my sampling. The maximum I got to was 42 degrees and 100% humidity. The sunscreen was melting off me faster than I could put it back on. And the water just evaporates. It's like breathing. You're drinking the air. There's that much humidity. So that's why your concentration of salt within the system gets so high. So that's possibly one of the reasons why they say the hydrodynamics and the conditions and salinity within the estuary changed so radically compared to what it was naturally. So your water quality, they've gone a bit lower than you. They've got a D, and you were sitting on a boundary category. Ironically, the physical habitat change has altered. So you've got a D and they've got a C. I haven't got it with me, but it's very possible that your category would have been an accurate assessment for the 2011 biodiversity report, because a lot has been done to re-establish some of the natural conditions. So because, as I showed you, you've got the Izimangaliso Wetland Park, a lot of the forestry, when I was there in 2013, 2014, a lot of the forestry was cut down and the natural vegetation restored. So it's possible that this physical habitat alteration, while the system has gone through a lot in the past, is looking better recently than what you might have expected. Interestingly, the microalgae, they've got an E, where you gave it a very near natural category. Again, the reasons for this is likely due to those alterations in the salinity. So we don't have a high pollution pressure, but when you have salinity that increases that much, you get some of these algal blooms where you get the species that are resilient to salinity change. And they're resilient to high levels of salinity, and then they absolutely bloom. You also get it because when your water level gets so much lower, you've got a high amount of light in shallow water, and you get these big changes in the microalgal community structure. So there, a big change, an E, which is sitting here, is 20 to 40% of natural. Macrophytes, you got it well, a lot of alien species in there, but such a big system with such a lot of habitat, and all within a reserve where it's mandated that you have alien removal. So although they are present, it's probably managed a lot better than a number of other systems in the country. Invertebrates, again, lower than you expected, simply because of those strong changes in the salinity and the changes in the hydrodynamics. So you probably would have had a much more regular opening of the mouth in the old days, which would have regulated the community. Whereas now you've had the mouth closed for a much longer period of time, which changes the community from what it used to be. You also, as I've said, have those blooms of certain species, which affects the oxygen, which can then cause the invertebrates to boom and bust for certain degrees across the system. Your assessment on the fish is bang on target at a D, so sitting at about between 40 and 60%. The birds they have at a D as well, which is fairly low. Again, this is probably not so much related to the specific estuarine habitat, so much as global change. So a lot of the birds that come and visit these areas are migratory birds. And because of changes in climate shift, we're seeing a big change in migratory birds, globally speaking. So probably a lot of this change is because of that. But still fairly good. You've got a C category where it's actually a D category. So you guys are doing very well in terms of your ability to rate at a rapid level the estuary health. So all of this will be included in the resource package. Yeah, I think a very good assessment going forward. Something I quickly want to show you, when we do this, we have slightly more detailed assessments. We don't just do one. Each of those categories are broken down into further categories, as I showed you in that first mind map. So we do a percentage calculation for all of the different aspects of the hydrodynamics, the water quality, the physical habitat, giving each one of those a score. Interestingly then, as I showed here, the biotic components are based on those three things: the species richness, abundance, and community composition. Salinity has its own page. So does DIN, which is dissolved inorganic nitrogen, dissolved inorganic phosphate, dissolved oxygen, transparency. They all have lovely tables like this, which when we have enough data and can do a comprehensive assessment, means a lot of maths and fiddling with the numbers, and makes for a much more in-depth estuarine health assessment.